Okay, so we were on number 3. It says this person earns $12 for the first 40 hours, and then 1.5 times that rate for any hours beyond 40. And it's asking if his paycheck was $714, how many hours of overtime or how many hours beyond 40 did he work? So we need to write our equation for this. I know for the first 40 hours, this person is earning $40. Sorry. For the first 40 hours, this person's earning $12 an hour. We have to add to that what they're making for those overtime hours. So it says that he's earning 1.5 times his hourly rate. Well, if his hourly rate is 12, we take that and multiply by 1.5. And then that's going to be multiplied by however many hours of overtime he worked. I know in this specific situation, I'm solving for the number of overtime hours it took for him to reach $714. So here's the equation I'm looking at. I can go ahead and simplify this. I know 12 times 1.5 is equal to 18. I can go ahead and multiply out the 12 and the 40. To get 480. I can subtract the 480 over. Then I get 18h is equal to 234. And I do 234 divided by 18. I get h is equal to 13 hours of overtime. On number 4, this is going to be a system of equations. We did this last year. So it says 600 people attended the premiere of a motion picture. Adult tickets cost $9 and children's tickets cost $6. If the box office receipts totaled 4,800, how many children attended the premiere? Okay, so the first thing we need to notice is that between the adults and the children, there were 600 people that attended this premiere, where we can say X is the number of adults and Y is the number of children. We also know that $9 for every adult plus $6 for every child added up to $4,800. So I want you to take a second and I want you to really think, okay, how do I solve a system of equations like this? Hopefully you remember that we need to solve this first equation for one of the variables. So I'm going to go ahead and solve it for y. So y is equal to 600 minus x. So I just go ahead and subtract that x over. Now I can take the 600 minus x and substitute it in for the y in the second equation where we dealt with ticket prices. So then I get 9x plus 6 times 600 is 3,600. 6 times x is 6x. So equal to 4,800. I can go ahead and keep going with this, combine like terms. I get 3x is equal to, I subtract the 3,600 over, and I get 1,200, which means x is equal to 400. Remember, x were a number of adults, because adults cost $9 each. So then I do 600 minus the number of adults will give me the number of children. So I can do 600 minus the 400 adults that I know attended gives me 200 children that attended the premiere. Okay, so this one was actually extremely difficult. It seemed really easy because it seems a lot like number 4, but it is a little bit different. It says a woman begins jogging at 6 p.m., running due north at a 6-minute mile pace. Then she reverses and runs due south at a 7-minute mile pace. If she runs to her starting point or returns to her starting point at 6:47, find the total number of miles run. So it's really important to note here that it doesn't say that she ran north and then south and then north again, which means she isn't passing where she started. So from where she started, she's running due north for some number of miles, and then she's coming back that same number of miles to return to her starting point. So these two distances are equal. So when I'm writing the equation, I know she's running a 6-minute mile for however many miles